Thank you, organizers of PyData. Thank you, Bloomberg, for hosting us. And a special thanks for the people who work on open source software who actually help us do our job much better and make it more fun. OK, so if you look online, don't look at the printouts. Today, we're going to talk about Jupyter. And you can read the XKCD thingy. OK. Right. So we're going to talk today about Jupyter Dashboards and how you can make your research more fun, more interactive. So there's my GitHub account. What I do for a living is I build Python apps. I work a lot in Jupyter. When I don't work on Jupyter, I cycle or turn up at PyData, PyCons, Python dojos, apart from tonight. OK, excellent. So right, OK, let's make it a bit of interactive. It's a workshop after all. So how many people work on using Jupyter? OK. And who doesn't work using Jupyter? So what do you use? So what do you use? Console, OK. Does anyone use Jupyter with kernel other than Python? Wow, OK, which kernel do you use?
Depends on the Python. Not mostly Python, but I do like sometimes serve around with R.
OK, excellent. So I'm going to talk later today. Yeah, so how Jupyter started is not, so people remember Jupyter is the same thing as IPython. IPython is for Python only. Well, that's not the case anymore. So today, we're going to have a look how to use Jupyter Dashboards. It's a project, so initially started by Jupyter Incubator. Some people who I think used to work here in Bloomberg worked on Jupyter Dashboards. Now it's in the mainstream repo. So we're going to cover like how do you, like if you want to like not just have it as a playground notebook, if you want to deploy it as a proper application that other people can reuse, like make it pretty, make it reusable, make it look something that other people want to use. How can you do it? One of the challenges that people say like, oh, in Jupyter notebooks, how can I parameterize them? How can I supply arguments into notebooks? How can I make them functions essentially? So that's one of the design decisions, I guess, but we'll show how to do that as well. Can you import a notebook? Can you say from notebook import some stuff, like if you have a useful function? So that's doable. And obviously interactive widgets and more interactivity. So I'll do the demo. And so my idea of today's workshop is, I do a couple of slides. I actually cut down on quite a few slides. Then if you were able to connect to my laptop running Python kernels and do what I'm doing sort of with me, but on your own laptops, that would be awesome. But let's see if we can set up this tiny little box. OK. There was, quite a show of hands when I asked about Jupyter. So why Jupyter? Because by now, I guess most of us work with data in some sort of, like, even if you're not a data scientist, but if you do development, if you do research, you deal with data, small data, big data, any data. So you probably, for your development and research, you use Python, and you probably like tinkering in Jupyter. And why? Because normally it just works. It doesn't crash too often, does it? It's got tons of extensions. I mean, I've talked to many people who use Jupyter. I've seen like many sort of workflows, how they sort of start with like, well, you work in Jupyter as an individual, but then you start sharing notebooks. You start like working in a team. So people start thinking about like, what's the best way of doing that? So there is a ton of extensions to help people. And when you go into Jupyter, and if you do like, if you want to display like a pandas data frame, well, it's there for you, nicely formatted. So there is some integration between popular packages and Jupyter. So those are good things. Yes, I mean, we know that as well. Last year here in PyData, we had an evening of lightning talks, and I think it was on the same evening where we had I think it was 5 solutions for improving source control for Jupyter notebooks. Why? Because Jupyter notebooks contain your code in a sort of JSON format, and which is not super easy to read by eye, but also they contain the output of your cells and other metadata. So even if you haven't changed your code, you want to commit your notebook to GitHub or your source code repository, it complains about a lot of changes, and it's very difficult to do the merges, compare, reviews. So source control is a challenge, but nevertheless, have a look at last year's PyData. I think it's on YouTube. So there were 5 solutions. Most of them do very similar thing. They strip out the output and some other attributes from each cell, and so that makes it very clean. So you can register that as a sort of GitHub or Git hook on commit, and that makes it very clean. I use it. It works. Yes, collaboration with Jupyter is difficult because you're like, well, this is what I wanted to show. It's like, oh yeah, I have this nice notebook. Do you want to have a look? And you start looking at the same URL, same notebook. You're connecting to my kernel, and you start if you start tinkering with it, so my screen first of all is going to be messed up, and I will get a message saying, do you want to reload? So the notebook has changed. Do you want to reload it? So we start sharing the environment. So that's suboptimal for collaboration. So we're going to see how we can improve that. Okay, well, some facts about Jupyter. Jupyter is much older, probably, than you think. So this is the original. So this is a screenshot of the original gist. I spoke to Fernando about this one, and he said, yes, so this all started back in 2001. 2001. That's a long time ago. Okay. Right. So I skipped the evolution of IPython into Jupyter. You can read about the big split, which has just completed recently. There was a tweet about it. There was IPython, sort of started with IPython console. Then it's Fernando said, oh, why don't we have it? Why don't we make it interactive in a web interface? So it was IPython notebook and IPython notebook server. Then a few years back, it was decided, well, actually, we can run a very clean UI, but the kernels will be completely abstract. So that's how Jupyter started, abbreviation for Julia Python R, kind of. And if you go on this GitHub link, last time I checked, I counted 87 supported kernels. Some of them are more kind of text only, but there are kernels for obviously Jupyter Python and R. A lot of people use Python and R, other kernels, but there are kernels even for C, for compiled languages. Right. So today I'm going to show you Jupyter Dashboards. What is it? How is it different from Jupyter? It's kind of the same, and it's very similar to Jupyter, and it's kind of the next step if you're working in Jupyter in your notebook and you want to productionize your notebook. So this is the direction. So I'll show you in a moment, but this is how I want you to see this project. It's been in Jupyter Incubator organization, I guess, GitHub organization, yeah, for quite a long time. And just earlier this year, graduated to the mainstream repo. So now it's it's as mainstream as Jupyter, IPython core, IPykernel, and similar projects. Right. So it's an environment, but it's kind of more secure and independent visualization of your notebooks. So you can share them easily. I'll show you in a second. In a way, it's similar to notebook server because you still supply your IPython or, well, Jupyter, sorry, notebook to the Jupyter dashboard, it still works on the same exactly file, the same code, the same idea. But it renders it in a single web page. And unlike Notebook Server, does not allow, so there are some security features which are by design. Like you're not allowed to, if you go into like press F12 in Chrome, and you're not allowed to execute JavaScript, so you're not allowed for the JavaScript to access your kernel, because you can execute arbitrary Python instructions, so that is not allowed. Okay, I talked a lot about this. Let's do the demo. Let me show like a typical workflow, what like someone would do. I do it quite often. So if I want to go ahead and tinker with a notebook and I want to actually make it interactive to help me visualize the data, first I go into Notebook. This is just Jupyter. Let's see, which one shall we pick? Oh, well, yeah, okay, the classic example. I guess everyone in PyData at some stage talks about Gapminder, right? Who knows about Gapminder? Okay. I understand it started with a TED talk, right? I could be wrong here, but I think Gapminder started as a TED talk. It's basically, let's put it like, it's some data and we want to be able to play that data through time. So that's what this notebook does. Let's see if that still works.
It'll make it so much easier.
Right, okay, so as you can see, this is,
Yeah, I'm just saying, this is the PyData level contents, and this is the PyData.
I'll make the font bigger in a moment, but just to give you an outline. So this is just a Jupyter notebook, and there's absolutely no more to it. So it does some imports. I use Bouquet. Well, actually, I use quite a lot of Continuum tools, so that's why I'm probably wearing a Continuum t-shirt today. So if there are any Continuum people here, I'd like to thank for their contribution to the society. Right, so this uses a Bouquet interactive plot. As you can see, you can do things to it. And yeah, I implement a widget. But the next step is quite fun. So then I go like, okay, well, I have all the components now. I go to design mode. So design mode allows me to take components and like drag them around, so reposition them the way I want. If we can connect you to the same network, maybe this is something that we can see if you do. Okay, and then I go like, now this is like, I'm happy with this notebook and this layout, and I go deploy. So this is like a productionizing step. So I'm happy for this to be shared with other people. I go deploy dashboard to dashboard Jupyter server.
I'll bring it back in 1 second.
All right. It spins up a kernel, so it takes, you know, there is some delay when it does imports and stuff. But look, it's a web page. And I would say, and it's interactive, and it's pretty responsive, okay? And it runs Python in the background. So I've done nothing like, apart from pretty sort of CSS, not much actually HTML there, just the PyData image. There was no there was no web design work here. It was all kind of drag and drop. It was it's all Python. It's all what you see is what you get, and in one step, you end up with something. So there's just a URL. Okay. Maybe we can see if we can share it with you. So that's just a URL. You go to this URL and you get this web application. So let's say you have some data you want to visualize, and I use this a lot for various applications. There are people who want to like, oh, I don't want to be like knowing how to load a particular notebook because it's, setting up Python environment, et cetera. So I just want to have a like web app or a URL where I can go and I can slice the data, or I can just leave it on my screen and monitor the data all day long. Okay, so that's great. This is like I will talk about alternatives, but this is just awesome. All right, so GapMinder. So what we have here? So we have an interactive plot here. So as I they say, oh, right, it's responsive. It doesn't let me make it bigger, but I guess you can see. So when I hover my mouse, I see tooltips. Tooltips are important. So that's one thing that I found. So the consumers of this kind of information, they love this kind of interactivity when they can hover the mouse and actually see the data. So this is something that Matplotlib does not offer. Matplotlib can be great for static plots. I mean, in the past I've produced like fantastic looking plots with Matplotlib, and you can go to as high DPI as you want if you want to print them, but they will lack interactivity at the end of the day. So here I can just go and say, well, this is what the essence of the GapMinder talk was. On the x-axis we have, well, first of all, what are these blobs? These are countries in particular regions. On the x-axis we have children per woman, like total fertility, and against life expectancy. So we want to see how that changed over years. So the data is from 1964 until 2012. So when I do this, you can clearly see the transition, and you can guess what so does anyone want to guess what what this big blob is? Yeah, so that's probably, so when you want to inspect your data, you don't have to, because otherwise you will have like a data frame or a panel. It's not so obvious when you look at the data as a time series. But when you do this, look at the transition, and you can pinpoint the years when, for instance, China made that jump. But then you can ask questions like, well, what else happened? I mean, any other countries? Like, what happened to other regions? So this is great for visualizing. Okay. Another classic example, borrowed from Bokeh apps. Bokeh server also supports like interactivity similar to this one. This is based on, I think it's actually, I haven't checked whether it's MDB, it's a movies database. As you start the notebook in Jupyter Dashboards, yes, it runs as a normal notebook, so it takes time so it doesn't cache the data, it just takes time to load the data first time. Right, so what we can, yeah, so there is a whole bunch of interactivity we can select. We have, this is a case of a multi-dimensional data. You have some, let's see what dimensions we have. I guess that's revenue, box office dollars, length of the movie, number of reviews, numeric rating, tomato meter, year. And obviously like the name of the movie, director, cast. So that's a pretty sort of big panel of data. So we want to kind of visualize and see if we can spot anything unusual. Oh yeah, so I think the colored points are the Oscars, at least one Oscar. Okay. So this would be great for, we can confirm that, for slicing the data. So basically, as I move the sliders, but also only, in this case, only when I release the slider, the plot updates. Okay, and the machinery behind the scene is actually trivial. It's all Python, And actually what it references Jupyter Notebook. Okay. Okay, one of the great things that I wanted to show here, which I guess is not really documented, but look, so not only this plot shows me like what film it is, but if I do this, I can select some points here on the plot. And I've made a callback to, so I interactively select some points on the plot. This is great, by the way. So this mechanism is great for like pinpointing outliers. So if you have 5 outliers, it's fine. But if you have 57 outliers, you don't want to be like copying and pasting like their IDs or data into like a data frame. So I just highlighted those outliers, and here we go. So those are the films. So search. Let's reset. How many Tom Cruise films do we have? No Oscars. Is that correct? Oh, no. Rain Man, 1988. Okay. So apparently, yeah, these are the search implies that these are the movie names which featured Tom Cruise. If that's incorrect, okay. Does that sound about right? Yeah. Okay. Okay. So I will post the link to the repo that has these notebooks, because these are the features that are quite interesting. So what happened here is we have a callback. Yes, so the callback is in JavaScript. The callback is in pure JavaScript, so this was not Python, because we have the front end. So here in the front end, in the web page, we use the mouse to select the points, and then that callback sends the data back to Python, which sends the data back as a table. So this is what happened under the hood, and IMDb it was called. Okay. Let us zoom in into what happened. I'm using bokeh plots to display the data because they give you sort of all the interactivity. Bokeh plots can get the data from a data source, and data source can be sort of static object, or it can be like Ajax, so you can populate it on a callback. In these examples, I use kind of a static data source, but you can substitute the data. So if something happens, you have an event, something changes, like when you change a selector, right? Those callbacks repopulate this data source, and the plot updates. Magic. Now, this is a bit of a tricky bit. So we're saying, right, okay, not only we do that, but when the source changes, we're going to register custom callback, which does all it does is a very simple thing. So it says like, okay, we want to get the indices of selected sort of X and of selected objects, and send them back using this line, this magic, back to the kernel. Console log saying, kernel, enjoy your data. And nope. This part is where we register the communication with the front end. So we're saying, yep. So that's going to be the name of our channel, foobar42. Why not? And we, when there is a message on this channel, this handler is going to be called. So it's communication channel on message, handle message, simple. So that's our storage. Like I put some data into a wallet, which is just a kind of dictionary, think of it. And then based on those indices that we supply, so what we did was selected a subset of indices. Based on that subset of indices, we do this crazy thing. So movies is a data frame, data frame.log. These are the indices driven by the selectors. So we have a full data set, which is tens of thousands of movies. So then we use our selectors. We select the first subset. So that's the wally.index. And then out of that subset, we get another subset that was selected using a mouse. So those are my indices. And I return at most 20 of them. And what I do is like data frame to HTML, just render it as a HTML table. Yeah, a whole bunch of CSS classes to make it look a bit prettier. That's it. It's like 3 lines here, 3 lines, 2 lines here. Plus the JavaScript magic. Let's make this interactive. Any questions? How do you? Initial thoughts? Like, why do I need this? How do I?
When you deploy this on a server, how this is safe for someone if I want to access let's say the source code and manipulate your code? How you can make this application really safe?
Okay.
Because most of the time when I access these things on the web, I can easily really do anything I want.
Well, yes. Two parts. So I'll answer in 2 parts. Yes, when you access a web application, you see only what's the web, so the front end of the web application, what it exposes to you. But like, let's say, how the web page was built, so the back end of the application, you don't see. So if you if you go onto Twitter, you don't see all the machinery that generates that web page. Yeah, you see all the all the DOM objects on the web page, but you don't see the machinery. The same here, the machinery and the the machinery behind this web page is your Jupyter notebook. Because it's a web application, so you don't actually want users to be like going ahead and changing the the code of your application. So it's kind of hidden away. It's referenced there, so the server knows how to find it. And what's beautiful, it doesn't even transform it into a different like object. It's still a notebook. So who serves this web application? It's a very thin Node.js web server. It doesn't do much. It just serves some web page, but all the rendering happens on. You still need like a pretty powerful server sitting somewhere under the desk or in a data center, doing all the Python rendering. Because now I'm having just 1 request. What if I connect all of you here and I'm just like suddenly I'm having 50 requests? So I have if I have 50 requests to. If I have them on my laptop, I have 2 cores. It's going to be challenging, So you need to think about scaling those applications. But to answer your question, it's like exactly like productionizing any web application. Some code is hidden away, but is available for you to edit and deploy. The beauty of this is deployment is super quick. I mean, you can say. Right. So add a message. So where do I want this? Yeah, that's fine. I can leave it there. And I go. So this is my deployment to production. So I just made a change, but like as a sort of developer, as someone who knows how to access this notebook. So you don't want your consumers to be changing your notebooks because source control is important and some control about like, this is the development environment, this is kind of production-like or QA or research environment. That's it, it's published. So I just made a change and deployed new code. So yes, I mean, if you come from kind of a software engineering background, you will say like, well, this may be desirable, maybe less desirable, because like it's so easy to deploy to production. So you have literally very few controls. But on the other hand, if you use your notebooks for the purposes that I described, like for analyzing data or for monitoring, where people get used to. So you can like bookmark this URL. They open it today. They open it next day. They're used to seeing this or similar screen. So I think it's a nice workflow.
When you deploy to the notebook server, is it possible to deploy to multiple notebook servers, or is like everything put together to use just one server and one? I don't know. If I wanted to make this graph available because it's relevant information, and I would like to make it available to a company where 50, 60 people would like to play with the graph, that could happen. Is there any scalability options? Or?
Scalability is possible, but I think it's a little bit challenging. So let's jump to that. I think let's discuss that right now. Because like now you've seen it in action. Now, what about the architecture? Looking for my slides. Here we go. Right. So what is Jupyter? Like, as with any kind of new technology, what are the benefits and what are the fixed costs and like variable costs? To answer your question, yes, a first-time deployment, like the setup is not super easy, but you can streamline it. Why? Because, well, we're talking about distributed services. We're talking about you have notebook server, you have the dashboard server, which is a different environment, and we have the box that hosts the kernels. So you need to make them talk to each other. What was that? Do I have a flip chart here by any chance? Because a flip chart? No. I don't think it would be. Right. It would be actually cool to draw the architecture. So this is kind of the architecture in there. So to answer your to answer your question, so the architecture is quite involved. So this kind of it's not multi-tier, but it's this distributed services. So we have essentially 3 pieces that talk to each other. So as I was saying, so web server, so that runs Node.js. It's very lightweight, can run on a Raspberry Pi, okay? If you can install Node.js on a Raspberry Pi. Notebook server is also lightweight. Probably cannot run on a Raspberry Pi, but it's like very low spec box. All it needs to be able to do is to run that front end. It doesn't even need to have like Python kernel installed there. So this is thin, this is thin. Now, the beautiful things is, so you have 2 environments, but you need to make sure that your code executes in exactly the same Python environment, like virtual environment or whatever you use, like Conda. So it's not like you develop you import pandas and NumPy in your development, then you deploy it and it says, oh, I don't have NumPy installed. Oh, actually it's not possible, but I don't have pandas installed on the in the Jupyter. So they have to be absolutely synchronized. How do we achieve that? Using, where is this guy? This. So this is a, I don't want to call it gateway because it's actually Notebook 2 kernel gateway, but all it does, it channels your kernel requests to the same box that is capable, like, so this should be like as multi-core box as possible. So how many cores can you think of? Like what's a good CPU for the size of your company? Yeah, that would be sufficient, because like even if each Python kernel is going to take 1 core, I think I think it's possible to host it. So in terms of scalability, unless you implement some load balancing solution like F5, normally this connects to a single box. But I think there was some discussion. I need to check whether it was on GitHub or elsewhere about being able to specify a swarm of boxes, like where to run. So because essentially this connects to remember, so the notebook server, after the big split, it doesn't know anything about Python or R or Julia or any other kernels. It just serves you the notebook. Okay, and it makes a request to the kernel. So there is some JSON config, so that's how it knows which kernel to connect to, and you also choose the kernel from the dropdown. But essentially, make that request go through this notebook to kernel gateway. 5 letters, but that's pretty important because it channels that request to a dedicated box that executes your code. And the same happens here. So when you are oh, fantastic! Thank you so much. When you are in your web page mode, it loads your notebook and then says like, okay, well, so which kernel shall I execute? And it uses kernel gateway to connect to that. Right. Demolite, yes. All right, so we're going to have a powerful box. So for kernels, I'm going to call it like, so kernel gateway. So that's the powerful box. Then you have your notebook server. And you have your dashboards. You have your dashboard server. So the typical workflow is, first of all, you need to set up your development and production environment. So these 3 boxes, they're not standalone. They know how to talk to each other. So you need to decide like on, okay, so which ports am I going to use for this guy? Then how this guy is going to access this guy, and how this guy is going to access this guy. And also, so there is 2-way communication here. 2-way communication here, and 1-way communication there. So the typical workflow is like you go into you open a new notebook, you start like designing your Jupyter notebook, you start executing your code. How do you execute your code? I mean, even if you do it today, you send your instructions from your cell to your kernel. That's a multi-core kernel. In this case, you are able to redirect it even to another machine. So you can send instructions and receive the output, through the network. Once you are happy with this notebook, and you have dashboards, Jupyter Dashboards installed as an NB extension in your environment, you go, and what I did earlier, you publish your notebook to your dashboard server, and then when you hit that URL, what happens is like dashboard says, okay, yeah, so I have this PyNB file, and another PyNB file. So I have this file, so I'm going to just execute it. How do I execute it? I load it cell by cell and send requests for execution to the same box. And this box is configured in exactly the same way as what you were using during the design phase. These files are hidden away from the user, so the user doesn't see them, which is kind of good because you can either display them in read-only mode here or not display them at all, because normally users don't really care how the web page is presented to them or what generates that web page. Now, Let's see if I have another slide. Oh, my demo. Okay, I thought I have a slide somewhere talking about the deployment. Now, this is the best thing about, like, think how you, if any of you come from software engineering background, think how you normally deploy your code, like Java, web applications, .NET. Normally there is a build process, there is some sometimes fairly complicated deploy script. Here is just as simple as copy your files across. So you develop your IPy notebooks here to deploy them. So you have your, let's say, if you want to run like Jenkins, or if you have a deployment script, what that would do is would take those files and copy them across, as simple as just a file copy operation. I mean, it may not be sort of robust from the timestamping and source control point of view, but it's just as simple as a file copy. All right. Okay, so I also, let's have a look at another couple of examples. All right, okay, so this is, oh, that's not nice, is it? Well, these are the dangers of live. Then what's going on? So we're still running. Okay. So I promised a few more things. I promised an example of a notebook that imports another notebook, and it's going to be interactive server. So let's see if my kernel is actually up. So the idea is this notebook is going to import from another notebook. So workshop ZMQ server, that's a notebook in my workshop folder. Here. That's a notebook. Okay, it doesn't execute any code, which helps because otherwise you will have to, it will execute on import, but I just want to be able to import this function and this function, and then I will be able to, so my idea, I will start generating some fake processes, but live, and I'll start sending messages, and another notebook will be capturing those, subscribing to those messages. Okay, let's see if it works actually. It's live. So, okay, so what happened here? I imported some code from another notebook. It's a hypothetical example, but quite often you want to reuse some code, and sometimes like you're like, I don't want to do cut and paste like into, you know, this code into 5 other notebooks. So there is a way, so just be aware. It's documented in this notebook importer. It's a cut and paste from GitHub, so this is not my code, how to the import machinery, but it works. It just shows the point that you can have some code in one notebook, import it, and reuse it in other notebooks. Sort of no real overhead. So what happened here starts as ZMQ server, so I'll start sending messages. So these are kind of my tickers. This is UTC time. Oh, okay. So that's UTC time, and I'm sending some values, and I think they follow some random walk. So let's see if we can actually view that. Is that the guy that can help us? Well, that box is ready to be configured as well. So several things actually happen. So this notebook is quite interesting. That's the trouble with notebooks sometimes. You have like a fair bit of, it's not a lot of code, but it's a fair bit of code. So like I want to show you something, and the actual interesting things are kind of hidden between the code. So this is where you specify the ticker, and when I do that, the plot should react somehow. So I want to subscribe to foo. I hit enter. Come on, should be a random walk. Okay, so that's a notebook that has just become live, and again, this is a bokeh plot. What happens? Once again, the callback is very simple. It listens to ZMQs, just subscribe to ZMQ messages, filters out, so because the messages come with different topics, it just filters out. I said I want a foo, so it filters out messages with foo and reads the value of foo and just appends that value to, remember we talked about data source. You apply to data source, send the update event to the plot. Look, it's live. And I mean, it's already deployed, but I can redeploy it again. It's the same code. So let's see if bar works. So this is now a web page. Look, an interactive, I have not spent much time on actually building this. It's, consider building something like that in a sort of web framework. It's fair, it's not difficult, but you know, you need to sit down and think how to do it. Whereas like if you, as I said, like if you want to put something on your side monitor and monitor it like all day long, or just view the data, this is great. I mean, it's, it takes literally minutes to spin up something like that. Now, this notebook has another interesting feature. Not only it's interactive, but I can supply. So let's reload it again. So now, before it starts taking, yeah, I haven't supplied any ticker, but I can inject external arguments into it by specifying them in the URL. And that's something, so if you read a lot of like blogs, you can do it in a notebook natively. It's not super easy, but it's even more challenging in the sort of dashboards, because remember that isolation of you don't have access from your JavaScript to your kernel, which normally prevents that thing. And if you like talk even like to core developers, they're saying, yeah, that's kind of difficult, if like not impossible, but next to impossible, difficult. Nevertheless, that's what I did. I just supplied one ticker. So this is the same page. I supplied a ticker, and this ticker is, so we are getting prices for foo. Or we can get bar as well. Well, we can actually put them side by side. Connect to that box. Yes. Okay, so who wants to make a better guess? So it supports all those four modes, but I think if I make it a router, no security, fine. Automatically obtain an IP. Maybe we can get you guys to connect to this laptop. Okay, and once again, what was the network name? Yeah. Oh, the one that I just changed, which I didn't take a note of, but I hope it's going to be the same. What's the best thing to do? Let's see if I can disconnect. Right. Oh, would I be able to see? Well, listen, 10. Okay, that's. No, I'm seeing if other people can connect to my laptop now. So it's 10. Yes, that's 10 109 10 109 3000. Come on. Oh yes. All right. I don't have an HDMI cable. Okay, so how can I send this?
Put it on the Slack channel.
Guys, if you want to connect, so this box is called wireless N. I was meant to rename it to PyData, but I think there was already a access point registered as PyData. So now if you access, oh, fantastic. That would be awesome. It's just I'm limited to this cable. I can disconnect this and move there, but it will take some time. So I know it works now, so I'd rather. Is that too long? No, that's okay. It's okay. I'll figure out. This one seems to be longish enough. Guys, so so before, let me just send it to. So it's going to be H. That's okay.
Say the IP again.
192.168.10.109, and the port is 3000.
Okay, I posted it. It's in the Slack.
Put it on the whiteboard.
Yeah, say again.
192.168.10.109. All right. 10.109, and then the port is 3000. Okay, it should be on the Slack channel if you can check. All right. Well, this is called Bring Your Own Equipment. So that's the box I had for. Yep. Is that long enough? No. Almost. Oh, come on, this is a stretch.
He's coming with a link cable, so we should be.
Right. Here we go. Okay, even better. Okay, is anyone online? Is anyone able to get to that? Come on, let's. Okay, which one are you looking at? Who is able to connect? Just wow. Wow, is that okay? Well, this is what I was talking about, having a limited number of cores. So let's see how busy this box is. Yeah, busy, but we're getting connections. All right, okay, so wow, that's a live test. So we have quite a few people connecting, so therefore it's quite busy. Was anyone able to actually load the page? It's on the Slack channel. It's also on the board. What we can do, we can also use port 3010. So that gives you the notebooks, and the idea of a workshop would have been, you open a notebook, you save a copy, like you suffix the copy with your PyData username, and then what we can do, we can open the, let's say, IMDb notebook, and we can see if someone can add, let's say, a button, like widgets is going to be widgets on button that when you click also updates the web page. So let's do. I can use the same IP address. Okay, busy. Okay. Can I restart, like, I did not host this like on Amazon for scalability. This is just my 2 cores. So what I can do is I can just restart, so that will kick you out, guys, and we can start from scratch, okay? Is that, any objections? All right. Okay, well, I was the first one to connect, so I'm able to open the notebooks now. So let's connect on the port 3010, and you should be able to see the notebooks. And then if we go into workshop, which one is? Yeah, let's open the IMDb one. Is anyone actually able to run it? Oh, there is some chatter. Sorry if I could borrow. I guess so. All right. Okay. Well, is that a good demo of scalability of how much one can do on a sort of single CPU? It's a decent CPU, but it's pretty busy. That's why we have Amazon, and Okay, next time I can see if I can spin it up on a more scalable infrastructure. All right, okay, dead kernel. Well, okay, that was a nice try. Right. So that was a demo of one of the shortcomings of Jupyter when it comes to collaboration. Yes, it's fine when you work on your own laptop. It's fine. It normally works when you scale like to a small team of people, 5, maybe even 7. I'm yet to count how many connections I had now, but it seems quite a few. And as you saw, the CPU was quite busy just serving the sort of notebook and executing. I mean, it was not executing much. So yeah, considerations, resources, and memory. As I said, it's possible to scale up using as DDoS. I've been DDoSed live. Right. Resources and memory. It's possible to scale up using F5 or similar solutions. What's actually important when you production, like when I was like, oh yeah, here's a notebook, let's make it a web application. Well, remember, it actually, so what the web application does is it does everything your notebook does. It does all the imports, it does all the, executes all the cells. So the runtime is important. Okay, so make sure that you pre-cache, like if you want to serve your notebook in a kind of seconds, in a matter of seconds, think about pre-caching your data so that your data is available when your notebook starts. Concurrency, well, tell me more about it. That was a live demo. I think that was the first time actually I've done it on my laptop. I mean, I've done this on powerful servers with, was it 24 cores, something like that. Obviously, yeah, so 24 cores would have been able to handle these many requests much better. This is just 2 cores, and it's not, yeah, it's an i5. Okay, so we seem to be doing better now. If you want to be able to kind of visualize the data and essentially have some interactivity, like you have drop-downs, selector boxes, it's a very popular approach, okay. There was just a recent tweet today or yesterday, just very recently, talking about like, yeah, I mean, all these things are great, but people are actually using IPy widgets. And IPy widget just recently had a facelift to the way the widgets look. And now actually IPy widgets are beautiful. The only thing is they don't work quite well with, I'll talk about compatibility. So IPy widgets and Jupyter, so a combination of those two, they are pretty cool when it comes to sort of making your research interactive. These are the contenders. Shiny is awesome, but does anyone use Shiny? What do you think? Yeah, I mean, it has the same issue. It runs like your kernel, so you can kill your kernels if you connect 20 people. Probably, it has the same shortcomings. But in terms of actually the number of lines of code you write to get something interactive, it's amazing. I think it's actually probably superior to Jupyter because, most common examples is just like 10 lines of code gives you like an interactive dashboard, right? Yeah. Now, Bokeh server is, I should be able to do the demo. Well, maybe not in the interest of time, but you can have a look at it. So Bokeh server is an alternative framework. It's very Shiny-like. So you specify how do you want to slice your data, and the results are displayed as it says. Oh, should be an H here. Okay, Bokeh. Bokeh server, and the results are interactive, so it's great. The only thing is it doesn't use IPy widgets, so it uses its own custom widgets. Spire is great. It's very lightweight. In Spire, you you write applications. It's kind of, I think, more similar to Shiny, because Spire is in Python. It's not flexible at all what you can do, but in terms of adding like drop down and select widgets is great. I have Zeppelin running on my machine. If I have time, I can show you. Zeppelin is pretty cool if you are dealing with large data, because that runs on, so it has like Spark and PySpark, well, Scala Spark and PySpark kernels, and it's a notebook. It's a beautiful notebook. It's different from Jupyter notebooks, but if you're working with like sort of biggish data that is not likely to fit into memory, and if you have access to like Spark infrastructure, that is something worth looking at. Now, not kind of new things, but if you're like, how many people use Vim and will not use anything else? Right, okay. So this is kind of goes into that direction where if you're like text only, so if you're like, Jupyter is a web API, no, not for me. Atom and Visual Studio Code. Do people use like Visual Studio Code? All right. I think it's great. Atom is also like, it's similar. It's a very it's an editor that is easily extendable. Now they have plugins, and they have plugins for Jupyter, so you can actually run your cells in both Atom and Visual Studio Code, and actually see the results. And you can see like data frames, and you can see the output of like Matplotlib, and actually Visual Studio, this thing supports even Bokeh, like JavaScript interactive widgets. And you still work in text on, kind of text only, yeah. So you know what I mean. But it's more text only than the Jupyter notebook. So all right, I'll spend some time taking questions. Thank you. Any questions or thoughts, or do we have a mic? Please do.
So for every new client, it spins up a new kernel on the back end?
Correct.
Okay.
Correct. Yes, similar to, I think similar to to Shiny as well. So yeah, so if your kernel, if you write your code in the way that makes the kernel busy, and if you spin up 50 clients, you'll probably run out of cores.
It wasn't clear earlier when you're deploying your dashboard, what services are you already running to allow that dashboard to be deployed?
Right.
Can you take us through running those?
Yes, I only mentioned, yes, correct. I only mentioned that the setup is a little bit tricky. I use Docker, so I have Docker Compose and Docker files to spin up the services, so that as few things go wrong during the live presentation as possible. But essentially, what I spin up is I spin up those three. I spin up these three services, and actually they are isolated as far as Docker is concerned. You can happily run them on the same machine, on the same CPU, on the same network, so they can coexist on the same kind of laptop, same environment, or they can be distributed. So my example in Docker spins them up as kind of separate instances, isolated on the network, talking to each other, but they share essentially CPU of my laptop. But yes, the setup, I'll post a link to the GitHub. So the setup is fairly tricky. It's not tricky if you're familiar with Docker, because you just bring your Docker recipes. You saw I restarted the services, so it doesn't take a long time. Okay. So this kills the existing processes, rebuilds, so Docker Compose build. I already have all the images, yes. Docker Compose up, starts the services, 3 services, 1, 2, 3. and 1 is running, 2 is running, 3 are running. So in terms of like once you make it work, it's fast and it's kind of understandable and debuggable. To make it work, yes, it's a bit challenging. I have to be honest. The challenge, yeah, the challenging part is compatibility. So there have been releases of Jupyter and IPython components that are not exactly compatible with each other, and actually some later versions. So if you, so they're currently available as pip packages. So if you pip install them, they would uninstall the dependency that the other package needs. So the solution to that is actually for someone to spend some time and Condify. In Conda, you can much easier specify which combinations of versions are not compatible. So it will find a subset of versions which are compatible with each other. Using pip in this case, yeah, so that's what typically happens. You install a later version, but it uninstalls and installs an earlier version of a package required by another component.
Could you export your package spec, perhaps, so we can see what the versions
Yes, absolutely.
that really helps? Is there any way you could put that on your GitHub repo?
It is in a GitHub lib. I just haven't sent a link.
The link's on Slack.
Right. If someone put it already, great. Otherwise, I will. I thought there was a Docker somewhere. OK, I'll find there was a Docker folder. So yeah, good point. So these combinations of versions are known to work with each other, and you know, if anyone wants to make it improve this infrastructure, you can work on Condifying those packages, because that will make it easier to see what's compatible, what's not.
Yeah, I have a question that I'm trying to get from your personal experience. Okay, what's the sweet spot of using these interactive dashboards versus something like Tableau, for instance? Is there like a sweet spot? Is there something that, in your experience, is much better done when you use Jupyter, not Python, dashboard than in Tableau, for instance?
It's the convenience. A lot of people are familiar with Jupyter. It's two things actually: convenience and time to market. If you are familiar with Python, Jupyter, you can spin up things very quickly. So what Jupyter Dashboards allows you is the productionize that very fast. But otherwise, yes, there is like otherwise. We just killed my CPU, so the same application would have been written much more efficiently as a standalone web application, but it's more effort and you need special skills. Whereas like if you are in the business of looking at data and manipulating the data, the chances are you are more familiar with Python and Jupyter than with, let's say, sort of web frameworks. So it's convenience and speed to market. Yes?
So I noticed in your comparison slide,
Yep.
you didn't kind of include any of the open source Tableau alternatives like Superset and so on. So you know
Superset,
by
I'm not familiar with.
so it's produced by Airbnb. It's a Flask app that can do dashboard creation, interactive visualizations.
How do you supply the data to it?
You can supply the data either using Python, either using your own Python functions or by writing SQL.
Right. Yeah, I'll definitely. I'm not familiar with that one, so I will have a look. Superset, isn't it? Yeah. Yeah. So there are a lot of alternatives out there. So
Yeah, I'm just saying that
right.
you've got this idea of single user, single process, which can get expensive.
It doesn't scale.
It's an interesting one, but then on the other hand, many organizations deploy something and only have 20 users.
Correct. This, as I mentioned, so the benefit of this is convenience and speed to market. So you don't need kind of specialist skills to develop something like that. Someone from DevOps can scribble or can install what I have here in Docker for the actual users. And the rest is all Jupyter, so it's all familiar to people. All right. Anyone else? All right. Well, thank you. Thank you for coming down.